Hello everyone, welcome to the map of mathematics. In this video we are going to solve an important homogeneous function problem. First we will discuss what is homogeneous function, and after that we will discuss the definition of a homogeneous differential equation, and after that in the next step we will solve some problems of homogeneous differential equation. We move towards our definition. First of all, we will discuss homogeneous function. We know that if we have f of x be a function of two variables x and y, and we say that the function f of xy is homogeneous of degree n. If we will replace this in this function, we will replace x and y by t of x and t of y, and we will get some power of tn and the same function f of xy. Okay, when we replace x and y by t of x and t of y, then we will obtain t times of given function f of xy. Then we say that our given function is homogeneous, and the power of t is known as the degree of that homogeneous function. Okay, now I can explain this concept by some example. If we have function f of x y is equal to example number 1 is equal to some xy square root. Okay, so for here which we can check that is this function is homogeneous or not, and what is its degree. So in order to check this one, we will replace just x by t of x and y by t of y, and we will get the new function in this form. T of xy is equal to this one. When we replace this x by t of x, we will get t of x, and when we will replace this y by t of y, we will get t of y, and these in which we t is multiplied by this t, and we will obtain t square into x y square root. And we know that the square of t will become simple t, and here we get square root of xy, and we know that square root of xy is equal to f of xy, so we can write it as t into f of xy. Okay, so when we can replace x and y by t of x and t of y, and we will get the function t times of given function f of xy. And here we can check that the power of t is 1, so we can say that this function is homogeneous of degree 1. Okay, here you just write it as it is homogeneous function of degree 1. Okay, and now we will move towards some and other example. So if we have a function in this form, f of x y is equal to x to the power of 10 plus y to the power of 10 over x square plus y square. Okay, now we will check this function is homogeneous or not, so we can repeat this process again. And first we will replace x by t of x and y by t of y, and we will get t of x into t of y is equal to, when we will put this x by t of x, then it will becomes t power 10 and x power 10, and when we replace t y by t of y, then we will get t power 10 and y power 10. Okay, similarly we can replace the values of x and y in the denominator, and we will obtain t square into x square plus t square into y square. After that, we will take common from t power 10 in the numerator, and we will get the remaining value in the form of x of 10 plus y of 10 over t square into x square plus y square. This t square is cancelled out by this, and finally we will obtain t power 8 into f of xy. Okay, because this remaining function is equal to f of xy. Here we can write it so, over when we replace t of x and t of y by t x and y, and we will obtain the function multiplied by t power 8. So here we can see that the power of t is 8, so we can say that this function is a homogeneous function of degree 8. Okay, so in this process we will check the given function is homogeneous or not, and similarly we will find its degree. Okay, thank you so much for watching my video.